morning. In the last class we have learned about the periodic table, the properties of periodic table and the shell and subshell capacities of atoms and the properties or the variations in the physical and chemical properties across a period, etc. And also in the beginning of this chapter we have seen that there are two anomalies that can be only explained using the property spin. So, without spin, we cannot explain the anomalous Zeeman effect and also the fine structure splitting. So, today we can go deep into some new properties, that is the spin-orbit coupling. Because of the spin-orbit coupling, the fine structure and the anomalous Zeeman effect, etc. were able to explain. So the spin-orbit coupling, it helps to explain the fine structure, doubling or fine structure, the splitting of the spectral lines as well as the anomalous Zeeman effect. So we can go deep into spin-orbit coupling. The spin-orbit coupling is the interaction between the spin and the orbital angular momenta of the atomic electron. The interaction between the spin and orbital angular momenta of an atomic electron is called spin-orbit coupling. Actually, the angular momenta, the spin is actually spin, magnetic moment is there. So, due to spin and the orbital motion of electron, we can have the spin-orbit coupling, or the interaction between the two momenta, two angular momenta is known as, or is termed as spin-orbit coupling. This is actually the magnetic interaction, because the spin magnetic quantum number and it is giving the spin angular momenta there. So, this is actually the magnetic interaction between the two angular momenta. That means the fine structure, the splitting of the spectral line, we can explain easily using the spin-orbit coupling. So this spin-orbit coupling, we can explain what is a spin-orbit coupling. For that we can use a classical picture. That means we know that in a classical model, the electron is revolving around the nucleus. This is the nucleus and this is the electron. This is the electron revolving. This is the nucleus. This is actually Z. The charge here is Z, where Z is the atomic number. So the electron is revolving around the nucleus. So with respect to electron, with respect to nucleus, the electron is revolving around the nucleus. But with respect to electron, it can be seen that the nucleus is revolving around it. So you can see that now we can see that the sun is revolving. Also the sun is rising at the east and it is going and setting at the west. So we can feel that the sun is actually moving, it is revolving around the earth like that. If from the frame of reference of with respect to electron, it can be seen that the nucleus is revolving around the electron. So that is the another picture from the frame of reference of this electron. This is electron. The nucleus is revolving around the electron. So we can see that this is a positively charged particle. So you can see that when the rotation is in this direction, actually this is in this direction, the plane is here. So if the positively charged particle is revolving in this direction, the magnetic field will be upward. So the magnetic field due to this here will be in the upward direction, perpendicular to the plane of the motion, that is, this is actually the B. So this electron is actually in a magnetic field that is produced by the revolution of the charged particle. Here it is nucleus, so this is in the, this electron is in a magnetic field here. And the electron itself having spin motion is having some angular momenta here. So this interaction between this angular momenta and the angular momenta due to this orbital motion, and there arises some magnetic field. So this interaction is known as the spin-orbit coupling. So this magnetic field acts on the electron's spin magnetic moment. It is having a magnetic moment because this electron is having a spin. So this magnetic field arises due to this nuclear motion, the motion of the nucleus this magnetic field will interact with the or acts on the electron's spin magnetic moment. So that interaction is known as the spin orbit coupling. This is actually an orbital motion and this is having a spin motion here. So these two magnetic field or this magnetic field interact with the electron's spin magnetic moment, thereby producing some interaction. That interaction is known as spin orbit coupling. So this interaction actually produces an internal Zeeman effect. That is the splitting of the splitting of the spectral line. The potential energy So the potential energy of a magnetic dipole moment mu in a magnetic field B is given by minus mu B cos theta. This is the equation for the potential energy. You may be learned this equation in the magnetostatics. So the potential energy can be given by mu. This is actually the magnitude of mu, magnitude of B cos theta. This is actually a dot product, mu dot B, actually a dot product, mu, vector B, a dot product. So this is magnitude mu, magnitude B cos theta. The theta is the angle between the magnetic dipole moment and the magnetic field. Here the magnetic dipole moment is actually the, we can see that for electron it is actually for the spin in the z direction. Actually we are taking the z direction, z component of this magnetic moment. So mu s z, this term we already have written in the starting while explaining the properties of spin, etc. So mu z s z, which is nothing but plus or minus mu b, where mu b is the Bohr magnitude. This also we have written in this equation also we have written in the starting of this chapter. Bohr magnitude. And this mu cos theta, which is actually the component of this magnetic dipole moment along the B field. That is mu cos theta is the component that is parallel to the B field. So mu cos theta can be written as plus or minus mu B, because this mu s z is in the z direction. So here the magnetic field is in the z direction, the upward direction. So mu s z can be written as, this is mu plus or minus mu B, but mu s z is actually the component of the magnetic moment along the B vector. So we can write mu cos theta is the mu s z. So mu cos theta is the mu s z. So mu s z is plus or minus mu B. So mu cos theta can be written as plus or minus mu B. So can be written as, this equation can be written as plus or minus mu B. There is two states in the presence of magnetic field, that is one is plus mu B and the other is minus mu B. If there is no magnetic field, only one state will be there. If the magnetic field is present, so you have two states that are one is in the plus mu B state from this without the magnetic field state, and the other next one is the minus mu B, which is down to the state where there is no magnetic field. So the initial spectral line can be split into two spectral for the spin orbit coupling. Due to this spin orbit coupling, the spectral line actually split. Because of this interaction of this spin vector capital S, the atomic electron will have an energy greater or lower by an amount mu b than the energy without the spin orbit interaction or without the spin orbit coupling. That means every quantum state is split into two substates in the presence of in the spin orbit, if there is spin orbit interaction, except for s orbit where there is no orbital angular momentum. That is for L equal to 0 we have the s state. So for that state we don't have any spin orbit interaction. So we can see that there are two possible states. So due to the spin, there are two possible substates for every electron in the in the quantum states. So the number of possible states is given by 2s plus 1. So you can see that there are two possible states. That means the s should have a value 1 by 2. S should always have a value 1 by 2. So because of the spin orbit coupling, we can see that there are two possible substates. So there are two possible substates. For spin angular, because of spin, these two substates are possible. So the total number of or the maximum possible states is given by 2s plus 1. So 2s plus 1 is equal to 2 gives s can only have value half. That is, the spin value is, or the spin magnetic momentum will take the value half. That is either in the up or in the down. That is the direction. The magnitude is only s is equal to half.